This next segment makes me a little sad. The problem we're going to do is a good problem. In the reaction of H2 gas plus O2 gas to water, how many grams of O2 are required to react with 7 grams of H2? And that's a good problem to introduce how useful the concept of the mole is. The reason why it makes me sad is that in any normal year would be together in Baker 200, and I would have 1 gram of H2 in the front of the room in the balloon mixed with O2, and uh, they would make a huge explosion doing this reaction when mixed together, and would scare the bejesus out of me. And it's something that's really very much part of the Chem 2070 experience in normal non-COVID-19 years. So I'm sorry about that, but at least we can learn about the mole. Okay, so we're going to do this problem, and we're going to do it in a way that can be generalized to more complicated problems. And the first thing we're going to do is that this reaction is not balanced. There's 2 O's on the left and only 1 O on the right. And I taught you a very complicated procedure for balancing, for complex balancing problems. But for simple ones, you can often do it in your head, and I'm going to do that right now. The balanced reaction is 2H2 plus O2 going to 2H2O. As you can see, we have 4 H's on the left and 4 H's on the right, 2 O's on the left, 2 O's on the right. And the way I'm going to first show you is a diagram method. So I'll call that up here, diagram method. And it starts with a nicely balanced reaction, and we then put the data in the problem directly beneath the chemicals, and in this problem it's 7 grams of H2. And in the diagram method, quantities of stuff are put inside circles, and then lines are the conversion factors. And if I've got grams of H2, I know that 2.02 grams per mole is the molecular mass of H2, and I can use the molecular mass of H2, which is grams per mole, to convert the 7 grams of H2 to moles of H2. 7.00 grams divided by 2.02 grams per mole is 3.465 moles of H2. Okay, and it's a very organized method. It's all in the same column, and we want to know in this problem how many grams of H2, and right now I've got the moles of H2, and the good thing is that once we have it in moles, we can look at the balanced chemical reaction. The balanced chemical reaction tells us for every 2 H2 molecules, 1 O2 molecule is used. For every 2 moles of H2, 1 mole of O2 is used, and therefore the number of moles of H2 and O2 will be exactly in a 2-to-1 ratio. And so I can take the 3.465, divide by 2, and I'm going to get 1.7327 moles of O2. And then how would I be able to go from moles of O2 to grams of O2? And the key is to note that O2 is 32.00 grams per mole. That's the molecular mass of O2. And so combining the multiplying the 1.7327 moles of O2 by 32 grams per mole, I get 55.4 grams of O2. And notice that here I've gone to only 3 sig figs because that's my starting value, and there's my final answer. And that's the diagram method. Equally important for this course will be a unit conversion method, and you really will need to know both. Sometimes you're going to use the diagram method, sometimes you're going to use the unit conversion method. Let me show you the unit conversion method. The unit conversion method, we start with the initial quantity, 7.00 grams of H2, and we're going to slowly convert the unit to the unit we want. And I'm going to have to write a little smaller. We know that 2.02 grams of H2 corresponds to 1 mole of H2. We know that 1 mole, 2 moles of H2 are exactly what's needed to react with 1 mole of O2. We now know that 1 mole of O2 is 32 grams of O2. There's that wonderful cancellation of units. Numerator cancels denominator, numerator cancels denominator, numerator cancels denominator, and we multiply that all together. We get 55.4 grams of O2. The same answer that we got before. When problems are complex, cognitively complex, the diagram method more often gets you the right answer. When the issue is just converting very weird units from one to another, the unit conversion method is the best. I will certainly write exam questions where either one method or the other method will be the best way to do it, and so you need to familiarize yourself with both concepts.